Yes, let's take up the first step, production of sulfur dioxide, which can be prepared either by heating sulfur or by roasting the metallic sulfides. That is, S plus O2 will give you SO2. Metallic sulfide here, FeS2, is not iron sulfide only. It is an ore of iron found in nature called iron pyrite, FeS2, with oxygen. Each individual element, iron as well as sulfur, will like to combine with oxygen. Thereby you get iron oxide and sulfur dioxide. Similarly, zinc sulfide with oxygen, both of them would like to combine with oxygen, and thereby you get zinc oxide and sulfur dioxide. Lead sulfide also will give you lead oxide and sulfur dioxide. Let's see how do we balance these equations. When we deal with the first equation, you have one Fe here but 2 here. So we simply start by writing 2 over here. Immediately, the sulfur, you can check, has become 4. 4 atoms of sulfur on the left hand side, so we write here 4. Oxygen is 2. Here oxygen is 3 plus 4 into 2, 8, which is equal to 11. But how do we make 11 oxygen here? We can have only a multiple of 2. So, in such a case, the odd part of oxygen can be made even just by writing 2 here. Because of this, now the oxygen has become, in this section, oxygen has become 6. What happened to the iron? 4. So we cut this and we write 4. Because of this, again, sulfur changes. 4, 2s are 8. So we cut here and we write 8. Now let's check the oxygen again. Right inside, we have oxygen 6 plus 8 into 2, 16, which is equal to 22. Now, can we make this 22? Yes, by multiplying with 11. So let's summarize. We have 4 iron pyrite with 11 oxygen atoms, oxygen molecules, to give you 2 molecules of ferric oxide and 8 molecules of sulfur dioxide. Let's try balancing these two now. Zinc sulfide with oxygen. We have 1 atom of zinc, 1 atom of zinc here, 1 atom of sulfur, 1 atom of sulfur here. Oxygen 2, but oxygen are 3. 1 plus 2. So best would be to make the odd oxygen section into even. Because of this, the zinc becomes 2. We multiply this by 2. Because of the sulfur becomes 2, so we multiply this by 2. Again, our oxygen changes. Now let's count the oxygen again. On the right hand side, 2 plus 4, that is 6. How do we make this 6? Right? You have to multiply this by 3. So let's rewrite 2, 3, 2 sulfur dioxide and 2 zinc oxide. This equation is similar and it goes this way. There you go. We are done with the first step of contact process, production of sulfur dioxide. You can use any of these methods. Now, what's next? Sulfur dioxide, when it is prepared in this furnace, there are a lot of impurities. So before the conversion of SO2 to SO3, we have to remove these impurities. So first, let's understand what are the impurities. The impurities are solid particles, which can be removed by a device called electric precipitator. You can see this dirty air coming. The positively charged and the negatively charged plates will take up the solid particles, and thereby you get clean gas, clean air. How do we remove the dust? Simply by passing it through water in water scrubber. So water will take away the dust from the gases. And you have arsenic oxide, which can be removed from an arsenic purifier. So thereby all these impurities can be removed. And then this pure gas or purified gas is oxidized, catalytically oxidation of sulfur dioxide to sulfur trioxide. In which tower? That's the name of contact tower. That's how the contact process name has come up, because this is a major step or the most important step of this process. It's a catalytic chamber. So who is the catalyst here? Vanadium oxide, pentoxide. Temperature 450. So sulfur dioxide, if I add more oxygen, it turns to sulfur trioxide. Plus a lot of heat is released. Now, in this process of catalytic oxidation, my friend here has a doubt. Hey, what's that? He says platinum is more efficient as a catalyst than vanadium pentoxide. Oh, yes, but we don't use platinum. Reason is it is more expensive, yes, and at the same time, it can be poisoned easily. If even if there is a little bit amount of arsenic oxide not clearly removed when we were purifying the gases, it can get poisoned and then it will not be as effective. So that's the reason we use vanadium pentoxide. Oh, you have one more doubt. Let's see. Why the impurity of arsenic oxide must be removed before passing the mixture of SO2 and air in the catalytic chamber? Why the impurity must be removed? Definitely, if the impurities are there, the catalyst won't be as efficient as it should be. So impurities must be removed or else it will lose its efficiency. That was a good question. Oh, what are the favorable conditions? Yes, because this contact chamber is a very important step, contact process, that is sulfur dioxide to sulfur trioxide. The conditions applied are that definitely this should be the catalyst. Temperature should be maintained between 450 to 500. Excess of oxygen, and there should be a pressure of 1 to 2 atmosphere so that we get the maximum output of sulfur trioxide. Let's move on to the fourth, second last step, conversion of sulfur trioxide to oleum. As you can see, it is happening in the absorption tower. What do we do in this absorption tower? We pour concentrated sulfuric acid, which combines with SO3. Concentrated should be maximum 98% concentrated, so that it gives you a new product. Can you combine? It's a combination reaction. So it will be H2, SO, S2, and O7. Right? And this is called pyrosulfuric acid or oleum. Again, you have a doubt. What is that? Yes, of course, this is pyrosulfuric acid. Then what's your doubt? Ah, okay. SO3 plus water gives sulfuric acid. Yeah, you're right. Sulfur trioxide, which is also known as sulfuric acid anhydride, means in sulfur trioxide, if we add water, we get sulfuric acid directly. Then why this step? This is what is your question. Good question. Why are we not directly adding SO3 with water? Well, scientists have tried that. It is not obtained directly with water because it does not dissolve in water satisfactorily. We need a good output of H2SO4. At the same time, when SO3 is dissolved in water directly, a lot of heat and misty drops of sulfuric acid is formed. So we don't have enough output in this manner directly. That's the reason it is first converted to oleum, H2SO4, H2S2O7. And now in this oleum, you are going to add water. So when water is added to it, you will get two molecules of H2SO4. That becomes the last final step because this is the industrial process. Industries require an optimum uh, production so that they make profits out of it. So let's summarize again. We have the steps involved in contact process, production of sulfur dioxide, which can be either by heating sulfur or heating iron pyrite, zinc sulfide, or lead sulfide. Any of those. Purification of gases, where we don't have any equation over there. Then this was the most important step where you use vanadium pentoxide or platinum, or you may just write vanadium pentoxide. You also need to write the temperature. Then sulfur trioxide to oleum, dilution of oleum to obtain sulfuric acid. All these equations and the steps are important to learn the contact process. And there you go, my happy chemicals. Oh, here comes H2SO4. Welcome to our family. How sweet. There you go. Sulfuric acid joins the family of chemicals. Thank you so much.